Hey, this is Math 2, Unit 8, Worksheet number 5. Wanting you to simplify radical expressions and then circle R for rational and IR for irrational numbers. Basically, if it has a radical like this, a square root of any kind in it, we're going to call it irrational. And that's pretty much it for today's lesson. So if you end up with a fraction or a whole number, it's rational. If you still have one of these crazy things, it's irrational. I'm just going to do the odd ones here on this side. You can do the even ones on your own. So here on this first side, we have a fraction, right? Negative 1/4 plus 2/5. To add a fraction, I have to have a common denominator. I'm going to go with 20 because 4 times 5 is 20. So to make that into a 20, I multiply top and bottom by 5. So this becomes a negative 5. To make this 20, I multiply top and bottom by 4. So that becomes an 8. And 8 minus 5 is 3. So I have 3 over 20. It's just a regular fraction, so it's going to be rational. Here I have the same radical, 13. So it's like having a same, like, anyways, same variable, right? Could be like an a, right? And so same term. So it's like 5a minus 7a. So negative 7, positive 5, left with a negative 2, and the radical stays the same. Don't do anything with that because it has a radical in it. This is irrational. Here we go, we're going to combine our like terms, so to speak. So we have a 3 and a 4, which make a 7. And here we have a 6 plus 2, which make 8. And the radical still stays root 17. Because it has that radical in it, it is irrational. That's all there is to it. Number 7, same idea. Let's combine our like terms. This becomes, when it's a minus, that becomes a plus 5. And that becomes a minus 7 root 2, right? When it's subtracting, you have to think about doing the opposite. So 3 plus 5 is 8, and then here, because of the same kind of base, the same radical, I have 7 minus 7, which is simply 0, so I have just 8 as my answer, so it's just rational, no problem. So I got rid of the irrational one, right? So you can get rid of the radicals if they simply eliminate each other, and you end up with a rational answer. Here we're multiplying fractions. This becomes a negative 3 times 4 is a negative 12 over a 45. Can I reduce that? I sure could. I could have done it earlier too. This becomes a 1 and a 3, same idea. So I end up with a negative 4 over 15. That is simply a fraction, so that's going to be rational. I'm done with that one. Here we are multiplying things out a little bit. All right. So I have 5 root 3 times 2 root 3. So the 5 times 2, that becomes 10. But a root 3 times a root 3 becomes simply a 3. And then 10 times 3 is 30. So my answer is 30, and that is a rational number. So I can multiply two radicals and end up with a rational number because they go away. Not always, because if I had it as a 2 and a 3, it wouldn't work out. Like this one. Here we go. So in this case here, well, this one does work out. What do you know? I have 4 times 2, which is 8. And underneath I have a radical 12 times 3, which is 36. 12 times 3 is 36. 36 happens to break apart into 6 times 6, so that can come on the outside. So I end up with an 8 times 6, which is 48. And I have a rational answer there. So I can have rationals when I multiply radicals. It can happen. Here though is one where I can have an irrational, because when I break this apart, I end up with 3 times 6 is 18, and inside of here I have 7 times 14. Well, 7 times 14 is really 7 times 7 times 2. See how I took the 14 and made it 7 times 7 times 2? I did that so I can just take that out. Take the 7 on the outside, and I have 18 times 7 root 2. 18 times 7 is actually 126, and I still have a root 2. That's going to be irrational because I still have that radical right there. And finally, this one, to clear that radical at the bottom, I do square root of 3 on both sides, top and bottom I should say. That puts me with a 3 on the bottom, and then over here I have 7, and I have the square root of, in this case, 75 is 25 times 3 times another 3, right? So why? Because 25 times 3 is 75. So now I have 25, which is 5 times 5 times 3 times 3 Those all go on the outside. So I have a 7 times a 5 times a 3 on the outside over 3. This is all getting a little bit crazy. Those cancel out, and so I'm left with just 35, which is a rational number. So there you go. Some crazy answers there, but just have to get comfortable playing with radicals and moving things around to get that work. Now, numbers 19 to 25. These are some different kind of questions, and you'll have these similar questions on your review sheet that you'll do next as well. So you just have to think them through and figure out what are they asking you to explain, and think of some examples. Okay. So what can you say about the sum of any two rational numbers? So any two rational numbers. Like number 1 was a rational number where you had -1/4 plus 2/5. So when I add two rational numbers together, sum is adding, I'm going to end up with a rational number plus a rational number is going to give me a rational number. That's generally the case when you're talking about what happens with two rational numbers. What about the sum of a rational and an irrational number? For that, you could look at number 5 and number 7, for example. So what you have here, when you look at 5 and 7, here's a rational number, right, plus a sum of rational and irrational. So in this one here, we have rational and irrational, and when you put them all together, we still end up with an irrational number. Here I have a rational and an irrational, but I end up with a rational because they cancel each other out, so that they went away. So on this case here, it's kind of the sometimes it's rational and sometimes it's irrational. It just depends. So when you add these things together, sometimes you get rational, sometimes irrational. There's not really a pattern for it. For 21, what can you say about the product of any two rational numbers? Okay, the product of any two rational numbers. Well, this would be like saying the rational, let's say you have the product of any two rational numbers. So if you had, well, 1/2 times 1/4, that gets you 1/8. So that's going to work there, right? No problem. If I had just simply 3 times 4, that's 12. So generally, the product of rational numbers is going to be rational. For the most part, you're going to get rational. Interesting, my notes said that you can get a sometimes irrational. So that would be a question I would have. Sometimes irrational. So that's a question I have. How? Like, give me an example. So if your teacher says, hey, there's a way you can get an irrational one, I guess just ask how and an example. There wasn't one in our samples that did that I saw. So I would just ask a question. Okay, I know for sure you can get rational. Can you get irrational? I'm not sure. So just ask a question. There, your teachers, they would know. Okay, what can you say about the product of a rational and irrational? So that'd be like a 6 times a root 3. So the product of a rational and irrational, that means you're going to end up with 6 root 3. You're probably going to end up with an irrational number. Okay? Can the sum of two irrational numbers be rational? We would say yes. So how can you get the sum of two rational to be rational? Well, basically you look for that cancel each other out and look for the 0. So let's take, for example, square root of 3 plus square root of -3, negative square root of 3, right? So that plus that equals 0, and 0 is a rational number, so you're okay. So it can happen. Can the product of two rational numbers be rational? Yes, that can be, because if I take the square root of 3 times the square root of 3, that becomes a square root of really what? 3 times 3. I have a partner there, so that becomes simply 3. Right? There you go. So you can end up with a whole number there and you're good to go. Okay, 25. Again, this will also be on your review, the same one here or something like this here. So just kind of get used to figuring out which one works for you and some examples. So they give you some example numbers here. We have 2, 6, that is one whole thing there. And we have that and that. Multiply them and it's rational. When you add them, it's irrational. So we want to look for an example here. So if I did choose two numbers, if I did 2 root 6 times root 6 and I multiply those together, do I get a rational number? Sure I do, because I end up with 2 times 6, because root 6 times root 6 becomes a 6, and 2 times 6 is 12. But when I add them, 2 root 6 plus root 6, that simply becomes 3 root 6, and now I'm irrational, right? So there's my rational, and there's my irrational for those values there. So I had 2 root 6 and root 6 were the ones I chose. Pick 2 more numbers. When you multiply them, it's irrational, and when you add them, it's irrational. So if I did 6 times, let's do 6 is my whole number here, and we'll do a root 5. Then I have 6 root 5. Yep, that's irrational. When I add them, 6 plus root 5 just stays 6 plus root 5, and it's irrational. Okay? And that's what they're wanting you to do. Just kind of look at the numbers, pick some that you like, and see what you can do with them. So I used 2 root 6, and I used root 6. I did 6 and root 5. I didn't use those ones. Could I? Yeah, I just didn't. There are lots of different ways you could solve those ones. Okay, the last set here. Simplify and determine whether each expression is equivalent to 8x 5/4. We want to get it to look like that. Can we make this look like that is the question. Okay, so in this first one here, I have 16 3/4 x 5/4. Now notice here, this x 5/4 already matches what's there. So can I get 16 3/4 to be equal to 8? Well, this becomes 16 4th root 3rd power. 16 is the same as 2 times 8, which is 2 times 4, which is 2 times 2. So the 4th root of 16 is actually equal to 2. So I still have the 3rd power. 2 to the 3rd power is 2 times 2 times 2, which is 8. And I still have on the outside the x to the 5/4. So does that match that? It sure does. We would say, yep, sounds good. Over here, I have x to the 5/4. Looks great, no problem. But I have just the 16. Can I do anything? Can 16 somehow equal 8? Nope, it can't, so I can't even try. Sorry. Over here, I have the 8 already. That's good news. What about this? There's the 8. This can be rewritten as x to the 5/4 power. Does that match? That matches, so we would say, yes, we're good to go. And finally over here, this is going to be like in 2 parts. Here's the 8, right? And here's the x to the 5/4. Like that part works here. I can get the x to the 5/4, no problem. But what about that 8? The 8 doesn't just kind of get a free pass. This is 8 to the 1/4 power. Well, 8 to the 1/4 is not going to equal 8, so that's going to be a no. All right, that's it. We'll see you next time for your review. See ya.